In this question, we're looking at upper and lower bounds. So the first thing we need to do is to find the error interval for L 252 and G 9.8. Starting with L, if we need to, we could draw a number line, put 252 in the middle, and we're rounding off to the nearest centimetre. So the nearest centimetre number before 252 is 251, and afterwards 253. The lower bound will be halfway between 251 and 252, and the upper bound halfway between 252 and 253. So we have 251.5 less than or equal to L less than 252.5. Moving on to G, again, if we need to, we could have a number line, 9.8 in the middle. We're now rounding off to one decimal place. So the number before 9.8 would be 9.7 to one decimal place, and afterwards 9.9. The lower bound will be halfway between 9.7 and 9.8, and the upper bound halfway between 9.8 and 9.9. So we have 9.75 less than or equal to G is less than 9.85. So, looking at the formula, T is 2 pi multiplied by the square root of L over G. We need the overall highest value for T. Firstly, we need to note that the units for L are centimetres, but the units for G are metres per second squared. So the lengths are different, and because we're going to combine them, we need them to be the same. So it will probably be easier to convert L into metres. We want the upper bound for T, so we take the upper value for L, 252.5 centimetres, and we need to convert this into metres, so that will be 2.525 meters. We can now work out the upper bound for T, which will be 2 pi multiplied by the square root of, and the upper bound for L is 2.525 meters. And in order to get the overall largest value, we need to divide by the smallest possible value. Dividing by the smallest possible value will lead to the largest possible answer. So we actually select the lower bound 9.75 as our value of G. So we're now able to work that out on a calculator, and it gives us 3.19748. The question says, give your answer to 3 significant figures. So we count 3 figures, 3.19, and cut the number off at that point. The number after the cutoff is a 7, so this will put the 9 up. So if we look at the 19 there, it will go up to 20, giving us an answer of 3.20 seconds, and that's the upper bound for the time period.